So for an example for our angular velocity and linear velocity, we're going to take a look at the following example. A Ferris wheel takes 20 seconds to make a half revolution. So a Ferris wheel is one of those big things that you ride that's at the fair. Looks like a giant circle with a bunch of spokes on it. And at the end of each of those spokes, there's a car for people to ride in. If you were to get into a car right here, then the amount of time that it takes until you rotate all the way around to the top is 20 seconds in this one. 20 seconds of just the best anticipation that you could possibly believe in. The radius of this Ferris wheel is going to be 16 feet. I want to find the angular velocity, the linear velocity in feet per second, and the linear velocity in miles per hour. So a couple relevant formulas that we have from recently. We have omega, that's our angular velocity, is equal to theta divided by t. We also have that our linear velocity is either equal to the arc length divided by time, or making some substitutions, arc length is also equal to r times theta divided by t, and theta divided by t is also the angular velocity. As a result, what we're going to do is start with the angular velocity. Now, it takes 20 seconds to make a half revolution. So first thing I'd like to point out is that a half revolution will need to be converted into radians. So a full revolution would be 2 pi radians. And so we'll multiply by the thing that we're converting to, divided by the thing that we're converting from. The 2's can cancel each other out. The revolutions can cancel each other out. This is going to be pi radians. So the angular velocity expressed in terms of radians per second, that'll be omega is equal to theta divided by t. Theta we just calculated to be pi. And the time we just calculated to be 20 seconds. So this will be expressed in terms of radians per second. So pi over 20 would be our angular velocity. Next up, for the linear velocity, I'm going to use the last form here, the r times omega, since we just calculated what omega is equal to. We'll take our 16 feet, we will multiply by our theta over 20. This will be feet times radians per second. We can reduce the 16 over 20 and call this 4/5 pi. The units on this would be feet per second. Now, because we are talking about a real-world example, as it were, getting an approximation for this is probably not going to be too bad an idea. So with that in mind, 4/5 pi, call that 4 pi over 5. Excuse me, and get a decimal approximation of about 2.51 feet per second. So 2.51 feet per second. Now, to help put this into context of how fast is this actually, what we're going to do is perform a little bit of stoichiometry and convert from our 4 pi over 5 feet per second, and we are going to convert this into miles per hour. Now, a couple things that are easily Googleable that I wouldn't necessarily expect you to know off the top of your head. Feet, there are, let's see, converting 2 miles from feet. 1 mile contains 5,280 feet. Additionally, I want to go from seconds into hours. There are 3,600 seconds within 1 hour. So what we're going to do is toss this whole thing into the graphing calculator, and we're going to see what this would be in terms of miles per hour so that we can relate it to how quickly we might be, say, driving a car. So 4 pi over 5, we're going to divide by 5280, then we're going to multiply by 3600. It looks like we are going under 2 miles an hour. This Ferris wheel is not traveling very fast, and that's okay. These are already probably not very safe to begin with, so it's good that it moves at a nice slow pace like that. So my expectation generally is going to be calculate an angular velocity and a linear velocity in feet per second. You can consider this just to be a little bonus education because, well, who doesn't love bonus education?